All right, scholars, welcome back to today's content on experimenting. So, we are starting to transition out of coming to terms with statistical ideas and putting them into practice via the experimentation of different statistical studies and trials. So we're going to describe the importance of randomness in experimental design, so I can use data from a simulation to compare data from experimental groups. I know I've got it when I can find the difference between two treatment means and use a randomization distribution to determine whether or not the result occurred by random chance. If you are watching this video and have never heard of the phrase randomization distribution, it occurs from grouping together all data and then randomly reassigning the data into different groups and finding the difference between the means of these new groups. So we have a satisfaction rating for two products. Which product in your eyes has an higher overall satisfaction rating, product A or B? Explain your thinking. Do you think that two different random samples of 5 people would lead you to the same conclusion? Why or why not? Right? Really emphasizing this idea of a randomization distribution. So we have a table here that represents data collected from the previous activity. It is your job to complete the final column. So this represents group 1 and group 2's mean, right, based on the satisfaction rating for product A and B. The actual mean, right, so a 4.4 satisfaction, a 3.6, and then the randomization distribution, so taking the data, spitting out new data sets and running the statistical analysis to find the means. So very simply, calculate the final column, which would be taking the first mean and subtracting it by the second mean. So 0.8, this would have a difference of 0, so on and so forth. After doing that, I would like for you to create a dot plot distribution of the difference of the means, so this final column of data here. What information is represented in the dot plot, and what percentage of the trials are the means from the two groups at least as far apart as the actual groupings from the warm-up? Right. I would like for you to think through what that actually means. Okay. What statistical, I have to sneeze. No, I'm good. Right. What statistical analysis allows us to successfully answer that question? Okay. All right. And in our final activity, this is going to set us up for the next couple of lessons where we're going to determine whether or not counting while exercise affects your heart rate. Here's a little breakdown of the data collection method. And I would like for you to identify which of the 3 methods would be good for dividing the class, so the results are based only on the counting and heart rate other than other factors. Whichever one you decide, make sure you explain your reasoning for that particular method. And we're all speculating here, so we're kind of reestablishing ourselves and exploring. Do you think that counting out loud will have an effect on the heart rate? Why or why not? We define a treatment to be the value of the variable that is changed between the two groups in an experiment. What would be the treatment in this experiment? And how would you design an experiment to answer the question, does counting while exercising affect your heart rate? Okay, so once again, if you're feeling a little unsure or unconfident, that is totally normal. We'll have a conversation together in class and tighten up, but we are definitely exploring over these last 4 to 5 lessons, and we'll have a much clearer picture by the end of the week.